Hello and welcome. In this lesson, we shall understand the interrupts provided by the AVR CPUs. An interrupt is a mechanism to inform the microcontroller the occurrence of an event which needs immediate attention from it. Depending upon the source of such interrupt, interrupts are classified as software interrupt and hardware interrupt. Software interrupts are caused by some faulty program outcome. For example, divide by zero, as name suggests, it is generated when a program tries to divide a number by zero. Breakpoints during program debugging, illegal memory access are also examples of software interrupts. Some microcontroller provide instruction to generate software interrupt. For example, ARM processor provides SWI instruction to generate software interrupt. Interrupts generated from devices such as keyboard or mouse are hardware interrupts. When a key on keyboard is pressed or mouse is moved, the hardware interrupt is generated. Plugging a USB device also generates a hardware interrupt. A memory address associated with an interrupt is called interrupt vector. When an interrupt occurs, the program execution jumps to the memory location. It usually contains an instruction to jump to the corresponding interrupt service routine. Each interrupt has unique interrupt vector. The list of all the interrupt vectors supported by a microcontroller is called interrupt vector table. The table is usually placed at the lowest memory address of the program memory. A routine which is executed when an interrupt occurs is called interrupt service routine. The address of the interrupt service routine along with jump or branch instruction is placed in interrupt vector. AVR core defines several different interrupt sources. Reset is also an interrupt. The Atmega 328 provides two external interrupts, 23 pin change interrupts, and interrupts from several sources such as timer, USART, analog to digital converter, EEPROM, etc. An individual interrupt enable bit is associated with each interrupt. This bit is used to enable or disable a particular interrupt. Global interrupt enable bit in status register is used to enable or disable the interrupt for the entire system. To enable an interrupt, global interrupt enable bit and the individual interrupt bit must be written with logic 1. The priority of interrupt is defined by its address location in the interrupt vector table. The lower address has the higher priority. Reset has the highest priority as it is placed at the first address location in the interrupt vector table. Then interrupt 0 follows. When an interrupt occurs, the global interrupt enable bit, that is I flag in the status register, is cleared and all interrupts are disabled. The user software can write logic 1 to the I flag to enable nested interrupts. All enabled interrupts can then interrupt the currently executing interrupt service routine. The I flag is automatically set when return from interrupt instruction is executed. In AVR cores, the interrupt vector table is usually placed at the lowest memory address of the program memory, but it can be moved to the start of boot flash section by configuring MCU control register. The reset vector can also be moved to the start of boot flash section by programming appropriate fuse bit. AVR provides two types of interrupts depending on if the occurrence of an interrupt is remembered or not. Type 1 interrupt has an interrupt flag which is set when the interrupt occurs. When an interrupt occurs while the microcontroller is executing an ISR, the interrupt flag is set and remembered until interrupt is handled or the flag is cleared by the program. If one or more interrupts occur while global interrupt flag is cleared, the corresponding interrupt flag is set and remembered until global interrupt flag is set and corresponding ISRs are executed in the order of the priority. Type 2 interrupt has no interrupt flag associated with it. Thus, interrupt occurrence is not remembered. If the interrupt condition disappears before the I flag is enabled, the corresponding ISR will not be triggered. The status register must be stored on the stack before executing the interrupt service routine and restored from the stack after ISR execution is completed. The microcontroller does not store or restore the status register. Similarly, the general purpose registers must be stored and restored. The program execution returns to the program once the interrupt service routine execution is completed. If an interrupt is pending during execution of an ISR, the microcontroller executes at least one instruction before handling the pending ISR. The instruction Clear Interrupt Flag (CLI) is used to clear the global interrupt enable flag in the status register. The microcontroller immediately disables interrupt upon the execution of CLI instruction. If an interrupt occurs simultaneously with the execution of CLI instruction, the interrupt is ignored until the I flag is set. The Set Interrupt Flag (SEI) is used to enable the global interrupt enable flag in the status register. If an interrupt occurs simultaneously with the execution of SEI instruction, the instruction following SEI is executed and then the interrupt is handled. The time period between the occurrence of an interrupt and the start of the corresponding interrupt service routine is defined as the interrupt response time. The Atmega 328 microcontroller takes minimum of 4 clock cycles to start the interrupt service routine as shown in the timing diagram. When an interrupt occurs, the microcontroller completes the execution of the current instruction. Then, program counter is pushed onto the stack. The stack pointer is decremented by 2. The instruction in the vector table is jump instruction to the interrupt service routine, which takes 3 clock cycles for execution. On completion of the jump instruction, interrupt service routine starts executing. If the microcontroller is in sleep mode, interrupt response time is increased by 4 clock cycles. This is in addition to the startup time from the selected sleep mode. The return from the interrupt service routine also takes 4 clock cycles. In these cycles, the PC is popped back from the stack pointer is incremented by 2, and the global interrupt enable flag is set, and the program execution returns back to the user program. We shall discuss the interrupts in detail in a separate section. With this, we come to the end of this lesson. Thank you.